All right, welcome back. Wish everybody a happy 4th of July. Hope you all have a good night tonight. If you're going out to watch fireworks, we did them last night. Had a real good show. Anyway, got a nice brand new Connex 3300 HP on the bench today. It's brand new, so obviously it didn't have any issues. So let's get right down, show you, show the performance of it. She came out really, really good. Again, nice 100% modulation, clean on the oscilloscope, clean on the spectrum analyzer. And I'm going to show you that right now, okay? So on low power, we've got it probably just a little over 2 watts. And the reason I go over 2 watts quite often. Sometimes 2 watts works pretty good, but and sometimes not. So one little benefit that I have on my bench is I have a headset. Okay, sometimes you guys might see it hanging around here. Okay, that headset is hooked directly into a demodulator, which is right in line with the coax, so I can actually hear exactly what's going out of the coax through the headset. Unlike people that use bench radios and such, you get all the squealing and feedback and everything. I don't get any of that, so I can actually hear exactly what's going out. And sometimes at 2 watts, and then definitely below 2 watts, you're definitely going to get a real crunchy sound through, or weak. It just doesn't have that good punch to it. So, sometimes you have to fine tune that up. So this one come out right around 2.25 watts on low, and unlike what other people say, over 105, about 105% modulation, with good, nice and clean. Okay, I know there's certain people that say you can't. Okay, so right there, let's just show you. That's 2 divisions right there. A good 4-to-1 ratio is double the power. So you'd want to go from 2 to 4 divisions on the scope. Okay, well, as you can see, we're just a little bit above that, and it's a perfectly good, clean signal, clean as a whistle, and as you can see, coming in right around 105, 106. Okay, on the modulation. Beautiful. Okay, so for those that say it can't be done, yeah, it can be done. And let's before we go to the spectrum analyzer, we'll just show you what it's doing on high. So high, we got it right there, around 8 watts. Okay, just a little over 8 watts. Okay, again, there is no set standard. Okay, I'm going to shut that off for a second. There is no set standard on where to set your dead keys, okay? And for those people that say there is a set standard done by the manual, most of the manuals are a baseline, especially when it comes to tuning the transmit section of the radio. Frequencies and all that, the PLL section, VCO and PLL section and all that, yeah, okay, I get it. The frequencies have to be absolutely correct. Anything off of CB Tricks, and don't get me wrong, CB Tricks is a very good place to get information, but that is not printed from Ranger Radio, okay? CB Tricks is input from multiple people, and it's a baseline on how to get a radio tuned in and aligned, okay? So there is no set standard, so Don't be fooled by these guys that are telling you it's a set standard by the manual, okay? So anyway, so let's just show you what it's doing on high. That's where we were at. I'm going to show you the 8-watt dead key, okay? We're just going to go out. We're just going to go out 4 divisions on a scope. We'll just leave it right where it's set, and it's going to go up 4 divisions, okay? That come out just under 100% modulation, okay? And the reason for that is when you set your dead key. Let's say you got your dead key. Let me see if I can explain this a little bit here. It's kind of hard to explain. Your transistors go into saturation. The higher you put your dead key, the more you try to swing out of them, they go into saturation. So I'll just show you what this thing's swinging on high, okay? Hello, breaker. Okay, about 35. I can get 35 out of it with a 10-watt dead key, okay? But that cuts the ratio back, okay? Then the higher you put your dead key, the more you're collapsing the ratio, okay? You want to open up that ratio, as much as you can. So to come down to an 8, you just opened up that ratio, because from 8, it's still going to swing 35, as you just saw, okay? And from 10, it'll definitely swing 35, but you collapse that ratio, okay? 35 divided by 10, 35 divided by 8. Now, could you go down further? You could. You could go down further, but what's the sense in having high-low power if you're going to squash the high power right down near the low power? Again, keep in mind, it takes 4 times the amount of power to gain 1 S unit on the receiving radio. So 2 and 8, right there, 2, 4, 6, 8. That's 4 times the amount of power. So I guess really, in essence, if somebody's far enough away and you went from low to high, they'll probably hear you a little better. Okay, so as we all know nowadays with the skip and everything, the way it rolls, if you're trying to talk locally or whatever, you're not going to gain much. But when it's quiet, when the skip's not rolling and it's quiet, somebody will hear that difference. But so, in my opinion, there's no need, and it doesn't make sense to squash that high dead key any further down than 8. And it really doesn't make any sense if you can't get 40 watts out of the radio by putting it at 10 watts, then it doesn't make any sense. Now, you probably can get 40 out of it if you crank the modulation or if you clip the radio. But again, as been said recently, that's what we do here. We clip radios and we put NPC mods in them. I think most of you that if you've watched any of my videos and you heard these comments, you're probably chuckling under your breath or even out loud, as I am, because you all know better, and the guy that made those comments knows better too. So anyway, I'm just having a little sip of coffee. Anyway, so we just showed you the low dead key, perfectly clean. The high dead key, perfectly clean. Low dead key, like I said, as you bring that dead key down, you get more dynamic range in the radio. So with a low dead key, the radio definitely will swing out a little more. And with this one, it's swinging out probably about 20. It'll bounce off 25 on low. And I guess we can show you that. Okay. About 20 on low. Hello, radio, check 1, 2, 1, 2, audio, check 1, 2, 1, 2, 1, 2. So figure it out. 2 into 20, that's 10. So 10 to 1. Okay. Beautiful. That's actually where I would run that radio. I would just run it on low, because it'll sound really, 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 really good. It'll be good and strong radio. And like I said, they're both, one's a little over 100 on the low, just under 100 on high. To set it any lower than that is absolutely ridiculous. You're buying a radio expecting to get a nice, loud, proud radio, and to have the modulation set to high 80s, low 90s is absolutely absurd. That's the way it comes from the factory. And when you go out and spend the hundreds of dollars on these radios, you expect a little bit more than that. And that's where a good alignment comes in and tune job comes in, okay? to get it to rock and roll, right? Okay. And I'm not trying to be a purist, okay? You could actually make the radio louder by cranking up the modulation a little bit and all that, but you really don't need to. The radio's going to sound with a good antenna and coax system. Radio sound mint. So let's get into the spectrum analyzer part of things, okay? Because this has been a little issue. I just want to touch base on it real quick. Nothing major, okay? So the way I set up my spectrum analyzer, and I'll try to explain this to you so you understand. I'll key it up. Okay, we're set for 50 kilohertz. Let me turn that mic gain down. 50 kilohertz span. That's 50 kilohertz from completely to the left side, completely to the right side. 50 split in half by your center frequency, 25 on each side. Each channel is 10 kilohertz, right? So if you're 25 on each side, you're 2.5 channels to the left, 2.5 channels to the right. So I kind of like to just show that because some of the, and I'll show you, we'll tone it down, but with some of the higher powered radios, 100, 200 watt radios, you got to be down that far because it really, when they're spanked, you get a lot of those spurious emissions and harmonics and distortion that go way out and really high. So the further you can open up that gap and show it, the better off you are. So let's just show you what it's doing. On low, okay. So there's the 1 kilohertz tone. Okay, full mic gain. I had to turn the mic gain back up. I had to turn it down because it was picking me up on the microphone. Okay, nice and clean. Okay, so let's just we're gonna go to 20. Okay, we're gonna go to 20 kilohertz, which is gonna bring us out 1 channel either side of the center frequency. Okay, if this radio was dirty, on a lot of those spurs that you're seeing down at the bottom would come right up, and I'm going to show you that. So, and the thing is a lot of people, when they say a radio's being a splatter box, not really so much the truth when it comes to, especially just turning up the modulation. It probably would not be a splatter box, but what it will be is overmodulated, and it'll cause a lot of distortion. So the only way I can describe how it's going to sound on the receiving end with distortion is, and I've said it 100 times, like cranking up the volume on your stereo to full blast. Okay, you might know the song and you might know what they're singing, but it sounds horrible, right? So that's the same thing. So would they end up being a splatter box? I wouldn't say 110%. Yeah, they'd be a splatter box if you crank the modulation, but they're not going to sound good. And 9 times out of 10, most people aren't going to respond to a radio that just sounds horrible, okay? And please do not go by what your talkback sounds like, okay? I've heard so many guys say, my radio sounds good to me. My radio sounds good to me. Well, your talkback is not a true indicator of what the radio sounds like. Okay, sorry to burst that bubble, but it's nowhere near what's coming out of the coax. So anyway, so we just put that out to 20 kilohertz, so which separates it by a channel on either side. Okay, so let's just show you what it looks like and what you can see, okay, under modulation. All right, now I'm going to crank the radio, okay? I'm going to crank the, first of all, before I crank the radio, if you want to be a purist, okay, the purest of the pure, okay, FCC says, I believe, anywhere from, I haven't, thought about it a long time, but if we look here, this is 2 kilohertz, okay? This is 4 kilohertz, and they say somewhere between, like, I think it's like 4 and 20 kilohertz removed from center frequency. They want you down around 35 dB, okay? And we're well into that, okay? So here we are at 2. We're down at this 20 dB. And when we get out to 3, we're down to 35. And then obviously at 4 kilohertz, we're down at the, we're down around the 50 mark as far as dB down, okay? So just to run by you real quick, at 20 dB down, it's 100 times less power, okay? So that one spike you were seeing, that sideband spike you saw is 20 dB down. That's 100 times less power than what the center frequency is, okay? And the center frequency is about 2 1/4, so 100 times less than 2 1/4, all right? Barely enough, probably wouldn't even light up an LED light bulb. Then when you get down to the 30 dB range, okay, so for go from 20, 30 to 40 dB, every time you go up in the dB number, you add another 0 to the power, whether it be minus or plus, because dB works in both directions. You can have minus 30 dB, you can have plus 30 dB. The math is all the same. So at 30 dB, you're 1,000 times less the power, okay? And then when you get down where I showed you where everything was down here in the mud, that's 40 to 50 dB. You're talking 10,000, 100,000 times less the power, okay? So anything down there doesn't affect the radio or the signal going out of the radio. The only thing we see down there, as you saw, is when we crank the modulation, all those spurs and harmonics rise, okay? And those are what add up on the watt meter, okay? Because I don't know if you were watching. Well, I guess I'll show it again, okay? Let's show it again. So there it is, you know, perfectly clean, okay? And we'll crank it up, okay? You saw all these come up considerably, right? The center frequency barely moved. I mean, it might have bumped up, you know, I couldn't even tell you how many tenths of a watt, hundredths of a watt, okay? But all this stuff that just popped up, that's what adds more power to your watt meter, and that's what fools the watt meter. So guys that are showing you, well, I can get you all this special wattage out of the radio, it's not coming out the antenna, okay? It's all adjacent to the center frequency. The watt meter, like I've said in the past, is just a voltmeter. It just picks up voltage, okay? So that's at 20, okay? Then we're gonna bring it down to 10, okay? To show you that beautiful, or what some people call the beautiful waveform, okay? So that, as you could see, everything is set perfectly correct. But what the problem is at 10 kilohertz, which is only one channel. So from center frequency, if you got 10 kilohertz span, center frequency, half a channel either side, okay? You know, certain individual is saying, well, you know, that's how you tell if everything's clean. That's where you see everything. No, that's pretty much where you hide everything, okay? So right there, as you saw at the 20 and the 30 and the 50, I don't even show 30, 20 and 50, whatever I showed, the radio was nice and clean, right? dBs were way down, okay? So crank it up, okay? Still looks pretty good. I could sit here all day and tell you that that looks absolutely symmetrical and beautiful, right? Well, that's not correct, because all these sideband peaks that you see that just came up, you want to get rid of those. Those have to go away, okay? You want to concentrate the power on the center frequency, not on the outside frequencies, okay? So we'll get that right up there where it was, 105% modulation, which is absolutely doable. Don't care what anybody says. You can see it right here. You just saw it for yourself. It's absolutely doable. You just need to know how to do it, okay? And you saw how the reason I use 50 kilohertz on the spectrum analyzer is just to show the customer the difference between their clip radio and a radio that's done the right way, and to show you where the fake watts come from, you know. Well, the guy told me, you know, 2 watts swinging 35, yada yada yada. That, well, he lied to you, okay? Because he tuned it with a watt meter, okay? And then again, just one other thing to touch base on the spectrum analyzer is when you check for your second and third harmonics, okay? So let's take a look at the second and third harmonics, okay? We're gonna go out 150 megs, okay? Now your second harmonic is at 54 megahertz, which is right here. This is your second harmonic, right here. 10, 20, 30, 40, 50, probably about 51, 52 dB down, okay? That's 100,000 times less the power than your center frequency, okay? That second harmonic is not affecting anything. It is so far in outer space or in the mud, whatever you want to call it, it doesn't exist. It's just that the spectrum analyzers pick it up because they're very sensitive, okay? And so, and that falls right back to the tuning of it, okay? So, can you tune that 54 megahertz out? You can. Probably by changing the bias settings on the radio. But that means 90% of the time you have to raise the bias up, okay? And when you raise the bias up, you start drawing more current. And again, current, not voltage. Obviously, you raise the voltage up as you raise the current up, but now you're starting to push everything right to its limit just to get rid of a harmonic that's over 50 dB down, okay? I'm just gonna show you real quick. I'll show you the chart real quick if you want to see it, okay? Everybody talks about doing things by the book, okay? 50 dB, 50 dB, 50 dB, 100,000 the power, okay? It's 100,000 times less power than the center frequency, okay? So that really, why would you want to put the burden on your finals by having to raise the bias up just to make that disappear? There's no reason for it. And the radios are designed from the factory. They put that 54 megahertz filter in, okay, that coil. Now you see they're spread a little bit. That's right from the factory. There's no spreading coils here. Those coils came spread like that from the factory because it's tuned to get that 54 megahertz as low as you can get it and still not jeopardize the tuning of the transmitter part of the radio, okay? So to try to get rid of that 54 megahertz by retuning your finals, it doesn't make any sense. It was all designed to get it down to where it's not going to affect anything, okay? And I see people, you know, some people say strictly no spread coils, put them back together, blah, blah, blah. And then they take a pair of regular steel pliers and squeeze them back together with steel pliers. Well, you can do what you want, but I suggest not doing that because the chances of chipping the enamel off this wire is very high, okay? And maybe if it's just out here on the edges, okay, it probably won't affect anything. But even playing with these, okay, you could take the chance of chipping the enamel off in between the coils, and then it's going to short out. It's going to be junk, and you're going to wonder why, what happened, okay? So number one, leave the coils spread the way the coils are spread from the factory on a brand new radio. Now, don't get me wrong. I've seen radios come in here, okay? I've seen radios come in here with this coil where they spread everything wide open and they grab that center winding right there and they pull it right out like you did to your Slinky when you were a kid, okay? That's a different story. That needs to be straightened out. But as it stands right now, the way that's set up, it's right from the factory, and we leave it that way because that's how it was tuned from the factory, okay? I think that just about covers what I wanted to cover on this radio. Just wanted to also get the spectrum analyzer situation kind of straightened out a little bit. Give people some room for thought. That's all. Think about what you're seeing. Think about what people are telling you, and look at the reality. Like I just showed you on the dB chart. Okay, that 54 megahertz is down 100,000. It's not even. The radio doesn't even know it's there. Okay, so. And the people listening, they don't even know it's there. So it's no need to go after that, okay? And as far as where you set your spectrum analyzer at, 50, 40, 30, 20, those all give you a good span of the adjacent channels. Once you get up to 10, that's only a half a channel. You're barely into the next channel's guard band. Okay, so you're just touching the guard band of the next channel over, so it doesn't really show anything. You want to see what's going on beyond that guard band. Not just within the 27, 20, 50 megahertz signal. So anyway, I hope that helps. Again, look, Connex 3300 HP. Gentleman will be picking this up tomorrow, and as you can see, he'll be very, very happy with it. And and by the way, I guess I should have shown it when the radio was brand new, but let's just take a look. Everybody worries about amperage draw. Okay, she's getting ready to shut down on me. Okay, amperage draw. Okay, this radio draws 2.8 on low and 4.8 on high, even with modulation. Hello, audio check, okay? So, done very, very well. And you accomplish, because it's probably up, stock probably up over 5 amps, easily up over 5 amps. So that's why we redo the bias in them, even on the new ones, and we do it by amperage draw. We usually can get that to come down, depending on the radio, we get it to come down an amp, sometimes even 2, okay, and still get good performance out of the radio. And with that less amperage draw, everything's going to run cooler. Your regulator's going to like you. Everything's going to be good. So anyway, I hope that helped clear a little bit of the air, and we'll catch you on the next one. Thanks for watching.